Okay, hope everyone had a good weekend. So last week we finished up, we were doing the differentiation formulas, right? And we finished up with the product rule. And we need to now talk about the quotient rule. And then once we do the quotient rule, we're going to do a bunch of examples. And then we're going to start the chain rule. And then after that, we'll do some examples. And then at the end, I'm going to do some quiz. But the quiz will be based on what we do today. So I will allow you to work together on the quiz. But just keep in mind that it will cover today. So last class, we saw product rule. Let me see how far I can go here. And I actually proved the product rule to you, right? I don't think I'm going to do the quotient rule because it's a little more involved. But it can be done kind of the same way I did the product rule, where you have to realize there's like a hidden zero and then you insert something and it's real weird and then it all works out. But just trust that it works. If you want to see it, you can come by my office sometime. Speaking of which, I will not be in my office today. So I have commitments after class. So just FYI, I apologize. All right, so quotient rule says that if you have two functions, f of x divided by g of x, and you want to take the derivative, it will be the derivative of f times g minus the derivative of g times f, the entire quantity divided by g squared. I mean, it looks, oops, g of x squared. That just looks bad. Let me put the product rule up here next to this. The product rule said that if you have two functions, f of x times g of x, and you want to take the derivative, that it's going to be f prime times g plus g prime times f. All right? Now, I want to point something out. In the book, if you were to read the book, it would tell you that the product rule, I'll do it in a different color. The book would say that this formula is actually, so the book's version of this is f of x times g prime of x plus g of x times f prime of x. That's what the book has for this right here. I just want you to see it's the same formula, okay? All they're doing is, imagine if I just switch these like this, okay? All right, just switch them like that. Because I can do that with addition, right? And then on these two, since that's multiplication, flip those over. So if I flip those over and move those in the front, I get this. And then that goes back here, and if I flip that over, right, I get that. So you see it's the same thing? You all okay with that? Now, in the book, it has the quotient rule as g of x times f prime of x minus f of x times g prime of x. I'm going to explain why I'm showing this to you, okay? G of x quantity. I forgot the squared on this, sorry. Squared on that g of x on the purple one. This is squared. I'm put the squared right there. Okay. So let me explain why I'm showing this to you. Like, let's confirm that these are the same formulas. Are these two the same? The only difference is flip those over, right? Flip those over, right? So when I was learning calculus, the book that I learned out of did the same thing. They had this and this right here. And if you look at this, these almost seem like you have to memorize two different formulas, right? Because it's like, this one is f then g prime, and then g then f prime. This one's g then f prime, and then minus f then g prime. So there's something different in the way the numerator, or the way this numerator looks from this, right? And then divide by g squared, you have to remember that. And to me, that was a little bit like, okay, two different formulas I have to learn, right? But the way I presented it here, these are the same formulas. I've just rearranged them. But if you look at it, see the product rule here? Do you see that in the quotient rule? The only difference between these two formulas is a subtraction sign and then divide by g squared. That's the only difference between the two. All right, so I think it's easy to remember them if they're presented this way. Does that make sense? So it's funny because when I have students that, you know, we go through our lectures and stuff like that, and then they take the test and they do either this formula or this formula, that tells me that they're getting tutoring on the outside, because the tutor's not going to use these two. Or they're going to use what's out of the book because that's what they learned. But do you see why it seems more efficient to memorize it this way? Yeah? So hopefully I can sell you on the idea of going with this instead of this. So if the book works through a problem, like if you own a solution manual, or if you have the free solution manual online.
What's the algebra behind your g of x squared on the bottom? Did you change it to, change it to g squared x?
Yes.
Wouldn't the square being on the outside of the brackets distributed to the x?
These two notations are equivalent. This means square g, but that also means square g. They're the same thing.
X isn't included?
Huh?
The x isn't included?
No, the x is not included. It's kind of like, remember in pre-cal when we had something like sine squared x? That was equivalent to taking sine x and squaring it, right? So it's like when I write g with the 2 here, x, g squared of x, that means you're going to square the g function, which means this. Okay, so I showed you, again, last class where this formula came from. We're not going to go through that again. And I'm not going to show you where this formula came from, but I invite you to come by my office and we can go through it if you'd like. I'll show you how to get it from the limit, but it's a little ugly. All right, so that's the way you'd seen the notation, but we use this so much that I have an even shorter way of writing it, just so you have it. I'm going to put it on the side. It's going to be off camera, but I'll use it throughout class today. The product rule, I'm going to say, is f prime g plus g prime f. All I'm doing is getting rid of the f of x, g of x, right? Just the f function times the g function plus the derivative of f times g plus derivative of g times f. And then the quotient is going to be the derivative of f times g minus derivative of g times f, all of that over g squared. All right, you ready? Let's do some examples. We'll start off with this one. All right, so I'm going to call it h of x equals x cubed cosine x. So what we want to do here is find h prime of x. So we want to find the derivative of this. So what we have to realize, at the beginning of everything is that we have a product. So does everyone see where the product is occurring? Multiplication is right here. This is not multiplication, right? It's cosine of x. So there's only one product happening here. And so what we can do is imagine kind of splitting this problem up into two pieces where that first x cubed function is like the f. Wow, that marker is terrible. And this one's the g. I'll use blue. So there's our f function, and then times the g function. So what I need to do here to get this answer is I need to take the derivative of f, right? Put it here, times g, and then plus derivative of g times f. So what is the derivative of f? 3x squared, right? 3x squared. So I'm just applying this formula here. Derivative of f first, which is derivative of x cubed, which is 3x squared. I'm using the power rule there, right? The 3 comes out front. And then I say times g. Now what's g? Up, careful. Just cosine x, right? So I'm not taking the derivative of g. I'm just writing g out, whatever it is. And g was cosine, right? And then I have plus. And then now the derivative of g. So derivative of cosine of x is negative sine x. So how am I going to write that with the... I have a plus there, and then I'm going to need a minus. I need to put that in parentheses, negative sine x. Because it's not good notation to write plus minus ever. So we'll just put it in parentheses. That's g prime. And then what comes next? X cubed times x cubed. So just to reiterate, this right here is f prime times this right here is g, and plus this right here is g prime, and then times f, right? And now we just try and clean this up a little bit, all right? And really on this, there's not much I can do, all right? So I'm just going to write 3x squared cosine x. And then over here, I realize that that plus minus will become a subtraction. And then the x cubed here actually can come out in front of the trig function. So I can put minus x cubed sine x. What I cannot do is put the x cubed inside here and make it x to the fourth, right? Because you can't pass that polynomial into the trig function. So that would be okay. We could box that up. That would be an answer. Later on, we're going to be setting this equal to 0. Because remember, this represents the slope of a tangent line, right? So you give me different values of x, and that'll represent the slope of the tangent line. And later on, what we're going to be asking ourselves is, you know, where are the highest and lowest points of this function? So like if that function, if we graph it, you know, it's doing something. And if we're trying to find these highest and lowest points, we're going to want to know where our tangent line, right, where the slopes are horizontal. That means where the slopes are 0. So we're going to be taking the derivative, and we're going to be setting it equal to 0 later. All right? So because of that, this is a correct answer, but because of that, if I had to set that equal to 0 later, I would probably try and factor it. So I would do something like this. I could pull out, let's say, an x squared, and I'd be left with 3 cosine x minus x sine x, like that. This would be correct. This is 100%. You get full credit here, right? But this is also correct, all right? Any questions? Good? All right. That was our warm-up problem. You'll get good at this with time. Once you've used the rule, you know, 100 times, you'll feel more comfortable. How about this one? Okay. How about this? I'm just using different letters here. J of v, okay? So it's a function, j, the independent variable is v, and it's going to be v squared minus 3v to the fourth times v to the negative 3 plus 5v to the negative 2. Now that looks like a pretty ugly function, and the derivative is going to be pretty ugly also, but let's just follow the rule, okay? Do you see multiplication? Right? You see multiplication right here? So this will split our function up. This entire thing over here is f. This entire thing here is g. All right? And now we just apply the rule. What is the derivative of v? And last time I think I started calling on people, and then I stopped. I think I only called on like one person. So we're just going to go around. And what I'm going to do is just randomly pick people here. All right, Hugo, I'll call on you since you seem so comfortable with this already. All right, Hugo, so I'm going to set this up for the product rule. I would like for you to give me the first piece here.
2v minus 12v.
2v minus 12v to the third power, and slap that in parentheses? Okay. So that right there is f prime. Everyone agree with that? That's a derivative. Derivative of v squared is 2v. Then here, The 4 comes down, hits the negative 3, becomes negative 12. Subtract 1 from the power, we get v cubed.
Yeah, I put v to the 5, that's right.
You wrote down wrong?
Yeah.
Okay. All right, that's just f prime, right? And then let's see, we're just going to go. Tara, where's Tara? Tara? All right, Tara, what comes next?
So it would be the -3 plus 5 v to negative 2.
Plus 5v to -2. Do you want to keep going? No? Okay, plus. I'm just keeping you on your toes today. How about Jason Morgan? Jason here?
Yeah.
Okay.
Need the G,
Jason's up. Yep.
Which one is it over Jason?
Oh, I have 2 Jasons. That's right. I called Morgan. I called Morgan. It's Jason Morgan. Sorry.
Okay, so it would be v minus 3 plus 5v minus 2, right? That goes next.
You're putting G prime next, right? G prime is next. So
Okay,
what
so
is the derivative of
It'd be
this?
negative 3v.
Okay, negative 3v. Negative 3v. Negative 3v to what power?
Negative 4.
Negative 4. And then you said minus 10v to the negative 3. And then I'll put that in parentheses. Right? Good? And finally, I'll put the last part because it's too easy. All right, last part is just f, isn't it? All right, there it is. Now, this is what I will consider, you'll hear me saying this in class, this is what I call the raw derivative, okay? That is the derivative, it is correct, but it's not cleaned up or simplified at all, right? But it is, in fact, the derivative. Just clarifying here, this is f prime right here, times this is g, and then plus, and then this is g prime right here, and then times, that's your f. Right? Everyone see it? Okay. Now, do we want to clean this up? I mean, what could we do? If we were going to clean this up at all, what could we do? We can multiply these together, right? Like this times this, this times this, this times this, this. So I could do a FOIL there, and then we could do like a FOIL here, right? Let's just do it just to see it, all right? Because the algebra here is definitely within reason. It's not crazy. It's not fun, but we should all be able to do this. All right, so what happens when I multiply 2v times 2v to the negative 3? You do 2v to the negative 2, so you're adding the powers together. You have a 1 here and a negative 3 here, so it's 2v to the negative 2. Okay, how about when I do 2v times 5v to the negative 2? So plus 10v to the negative 1, okay? And then what about this multiplication here? Negative 12, that's it, or minus 12. Because v to the 3 times v to the negative 3 is v to the 0. V to the 0 is 1. And so it doesn't go away, okay? You still have the negative 12 there, times 1. So, all right, what about here to here? Negative 60. V, that's it. 3, take away 2, you just have 1v. So that's the first part. Then you have to do the same thing over here. Okay, so let's see. Here to here, negative 3, v to the negative 2, all right. Then here to here, positive 9, so plus 9, v to the, oh, there is no v. It's just plus 9, because the negative 4 and positive 4 give you v to the 0, which is 1. Negative 10v to the negative 1. And then finally, plus 30v, right? Plus 30v. And we actually have some like terms in here, don't we? We do. So there's really no like correct way to write this in terms of order. You remember with polynomials, you always like to go in descending order, like highest power down. That's when you have just a polynomial. This is not a polynomial because we have negative powers, but we can still do some sort of, descending order. Yes?
After we fold that out right there, you had a plus sign in between those two.
Where?
The plus sign in the middle of the whole term, above that one, go up. Look in the very middle, there's a plus sign.
a plus.
In the very middle of the term.
Wait, hold on. There's too many people talking. Where?
Wouldn't that positive factor into that second term?
Where?
No.
It doesn't factor right now.
In the raw derivative in the center, or the center of the raw derivative.
The plus. Let's talk about the plus.
This plus.
Oh,
Oh, that.
It goes away.
Okay. Well, look. When you do these two together, right?
Yeah, it's all.
Okay. You get a negative number, and when you add a negative, it's still negative. So it does not factor in. Now, when we get to the quotient rule, that negative is going to be very important. All right, let me get all my, let's see, I guess I'll start out with my V's. I've got 30V and negative 60V, so negative 30V. Now, that would be V to the first power. If I come down on the power, I'll have no power, right? Which would be constants. So where are my constants? Let me get rid of the ones I already took care of. So I've got a plus 9 here and a minus 12, and those two together give me negative 3. Okay, so this is like V to the first power, V to the 0 power. Next would be V to the negative 1, which would be this one and this one. I'll put those together. They're gone. Okay, so those are gone completely. And then finally my V to the negative 2. I've got this one and this one, so that's just one of them, right? Minus V to the negative 2. One other way you could write this, negative 30 V minus 3 minus 1 over V squared, right? You could even get a common denominator, like put this over 1, put this over 1, make a common denominator of V squared. If you did that, you would have negative 30 V cubed minus 3V squared minus 1 all over V squared. So do y'all see what I did here? I did it in my head, but I did this over 1, and then I multiplied V squared top and bottom here, V squared top and bottom here, and then put them all together. If we were going to have to set this equal to 0, right? If I had to set this equal to 0, which you will have to do later, then I'd probably want to go to this and then go to this and work with this set equal to 0 instead of this. So the algebra, most students don't have that much of a problem actually implementing the rule, like doing the f prime g plus g prime f. Usually the problem comes after that. It's the algebra after it because it's going to be messy. This is still not messy. This is still pretty clean, actually, what's up here. All right, let's keep going. Y'all feeling okay with this so far? Haven't done any quotient rule yet. But I think it's time. Let's see. You ready? All right. All right. How about, well, you know what? Before we do that one, let's do something that has a weird variable in it. H of theta equals theta sine theta minus pi theta. All right. So we want to find h prime, all right? This is what we're looking for, h prime of theta. So keep in mind, the variable here is theta, right? Just like the x was before. So what do you all see happening here? We actually have a couple of things happening.
Theta multiplied by sine.
We do have multiplication. We do have a product, theta times the sine theta, right? But then we have subtraction. And we know when we take derivatives that if we have a plus or minus between things, we can do them individually, can't we? So what I'm going to do is I'm going to take derivative of this, and then I'm going to take derivative of this separately because of the subtraction. When I take the derivative of this, I will have to use the product rule, right? And when I take the derivative of this, what will I have to do? Is that product rule also? Well, pi is a constant, right? So that expression right there may as well be like 3x. You see, it's a variable with a number in front of it. So what's the derivative of 3x? Just 3, right? So what will the derivative of this be? Just pi. Okay? So I'll do these separately. Understand? Now, here I go. H prime theta equals, now, again, make sure you understand, we are going to do a product rule right here. This is like my little f, this is like my little g right there, right? And then this guy over here is like its own little problem I'm going to do and just slap that answer on the end, all right? So we have Jonathan. Is Jonathan here? Salinas? Yes? All right, you're up, Jonathan. So you're gonna give me the derivative of this right here. So what are you gonna start with? Derivative of theta, which is? All right, so what's the derivative of x? 1, right? Because x is the variable. This is the same problem, except I'm using theta instead because it screws your brain up a little bit, right? So you go theta, derivative of theta will just be 1. Clear with that? Okay. And then times what, Jonathan? G, which is sine. Okay. I'm going to have you keep going. Then I'm right here in the formula, right? So plus, yes? And now derivative of sine. Remember it or no? That's one of the ones you have to cosine. So in this case, cosine theta, right? Cosine theta. You're almost there, Jonathan. So you've got this now. Last piece times theta. And that theta that's tacked on here on the outside, again, cannot join that theta, right? So it's gonna slide out in front. Now that's just the derivative of this, right? Just this. Now I need to do minus the derivative of that, but we just said that that would be pi, right? So minus pi. We all good with that? I'll just clean it up a little bit. I don't need the 1 in front, right? I don't need to write that. So I can write sine theta, and then here I'm going to slide that theta out front, plus theta cosine theta minus pi. There's your answer. Questions? We're good? All right, so that was a good example because we got to use a variable that was a little different. Okay, how about this one? How about f of x equals x squared plus 4x over x to the 5th plus 7. All right, so we finally have a quotient here, right? Is it obvious to you that that's a quotient? Yes? Okay. So now, when I'm looking at this, I'm looking at the entire numerator as being like my f and the denominator being like my g. Now, I did this on purpose. This function is called f, isn't it? And then I'm saying it's like f over g. This is kind of bad notation because I'm using f twice, but it's just to match the formula. I have function over function, right? I didn't write this is the one we're using, right? So when I have a function on top of a function like this and I want to take the derivative will be, all right. So here's what I can do. Right now, without doing any work, I can write that down, can't I? Because no matter what in the formula, no matter what, the bottom is just g squared. So you're always going to have whatever the denominator was here, always will just be here squared on the bottom, all right? And then the rest of it, the top, is basically the product rule with the subtraction instead of an addition. Understand? Okay, so let's go through this. What's the first piece going to be here? F prime, which is 2x plus 4. 2x plus 4 goes here. And then times what? G, which is just x to the 5th plus 7. And then very important now, minus g prime, so the derivative of the bottom. 5x to the 4th, and that's it, right? It's just a single term. The derivative of this is just 5x to the fourth. Derivative of 7 is 0, so it's gone. And that means I don't need parentheses around this, do I? No. And then what comes after that? Times the x squared plus 4x. And that one I do need in parentheses because it's two terms. So illustrating again, this right here is f prime, this right here is g times g, minus this right here is g prime times this part is f, and of course this right here is g squared. Everyone see the formula there? Okay. And I'm going to clean it up. And what I mean by clean it up is I'm going to do the algebra. I'm going to multiply, I'm going to expand this out, I'm going to distribute negative 5x to the fourth through, and I'm just going to take a look at what I've got. All right? So distributing here, 2x times x to the fifth would be 2x to the sixth. The next term will be 14x. Next term will be 4x to the fifth, and then plus 28. So that is the expansion of these two. And then we have this negative 5x to the fourth is just going to pass through to those two. So what would my first term here be? Minus 5x to the sixth, and then minus 20x to the fifth. All of this over x to the fifth plus 7. And I'm not actually going to square that out. I'm just going to leave it. You could expand it, but most of the time we just leave that one alone. Because in the top, we're most likely going to get some sort of algebraic simplification, which you can see we do get some things to go away, right? Or not go away, but combine together. So how many x to the sixth do I have? I've got 2 of them here, and then minus 5. So negative 3. X to the sixth. Now x to the fifth, got what, 4, and then minus 16. X to the fifth. So what have I done? I've done my x to the sixths, my x to the fifths. I just have an x term here, 14x, and then plus 28, and all of this over x to the fifth plus 7 squared. And that's good right there. So this right here is the raw derivative. When I'm grading your test, I'm looking for this first. I'm looking to see that you got this part right. And then, you know, let's say if the problem's worth 10 points, this right here gets you like 6 to 7 points, all right? 6. And then this will give you the rest, the full credit. So like 60% of the problem is can you apply the rule correctly? And then the rest of it is can you algebraically clean it up? All right? All right, let's move on. Let's do some more. There's no such thing as doing too many of these problems. All right, some different notation here. Y equals root x plus 1 over root x minus 1. Want us to find y prime. So all we want to do here is look at it, analyze it, see what rule we have, right? We have quotient rule again. So the entire numerator is f, the entire denominator is g, and then we just apply the formula. So we're going to be doing f prime g minus g prime f all over g squared. So would you like me to just do the g squared now, or it doesn't matter? You could do all over g squared right now if you wanted to, or you could wait and do it later. It's up to you. Just don't forget it's there, all right? I never really put it down first, but you can. The reason I don't put it down first is I don't know how long this division bar needs to be yet, right? I don't know how many terms I'm going to have up here. So let's just start with our division bar and just go with it. Let's see. Maybe that'll be enough. I don't think it will, but. All righty. The top left piece of this is f prime, right? So what is the derivative of f? 1 over 2 root x. That's it. So two terms, I can do them individually. Of course, the derivative of 1 is 0. And the derivative of root x was one of the ones I told you need to just get it like automatic now. Derivative of root x is 1 over 2 root x. That is f prime. Then I'm going to say times g, right? So what is g? Root x minus 1. I need to put that in parentheses. That's f prime g. Minus derivative of g, which again is 1 over 2 root x. The derivative of f and the derivative of g turn out to be the exact same thing here, don't they? Okay, and then times f, which is root x plus 1, and then all over the denominator squared. When you square the denominator, when you square this, right, you cannot just square each one. We've been through this, right? So that is what you have to have. You cannot, this is incorrect. X minus 1 is incorrect. You can't just square each one, all right? Well, will we get to clean that up? This looks bad, but it's actually not as bad as it looks, all right? Let's multiply this through. When you multiply that times that, you have a root x on top and then a root x on the bottom, which cancel each other out, right? And so all you're left with is like a 1/2. So I'm going to get a 1/2. And then what about this 1 over 2 root x times negative 1? I just get negative 1 over 2 root x. All right, be careful here. When I pass this through, I'm going to treat it like a negative. And this times this, the root x's cancel out again. I get minus 1/2, right? And then do this one times this one. Again, a negative times a positive, you're going to get negative 1 over 2 root x. All of this over root x minus 1 squared. The halves cancel, right? And then, what do you have here?
Minus 2.
Yeah, you have minus 1 of these, and then minus another one, so that means you should have 2 of them, right? So the top really looks like this. Minus 2 over 2 root x. And the 2's will cancel. But that's all over root x minus 1 squared. Does this algebra seem okay to you? Or, I mean, I think everyone's going to be at a different place here in terms of their comfort with the algebra. But do you remember me telling y'all earlier in the semester, like calculus, what makes it difficult is the algebra? I mean, this is why, because you've just got to be super comfortable with manipulating things. And all right, these two cancel. And so we have negative 1 over root x over root x minus 1 squared. But that's not the answer the back of the book will have. The answer the back of the book most likely is going to have is this. Negative 1 over root, parentheses, root x minus 1 squared. That's the answer in the back of the book. So how did they do that? They look at this as being a fraction right here. And remember that a fraction divided by a fraction is the same as multiplication of the reciprocal. So if I take this and flip it up like this, right? If I take that and flip it, the 1 will be on top. And on the bottom I'll have the root x minus 1 squared. That's not here anymore, right? And then when they multiply these two together, negative 1 and 1 give you negative 1. And then these, they just put them next to each other. So you get that. We good? Okay, let's do something else. How about this one? How about x cubed plus 3x over x to the 4th plus x squared plus 1. How about I give you like 2.5 minutes to see if you can come up with the raw derivative of that. Just the raw derivative, and then we'll see about cleaning it up. When you get it, raise your hand. Like when you have the raw derivative. Just I want to see where people are, okay? All right, that's the raw derivative. All those parentheses have to be there. You can't, those are not optional. Okay? Any questions on that? Everyone's comfortable? All right, now the distribution. The hardest part of this, or the most dangerous part of this, is this minus sign, because you have multiple terms here. This is the first problem I've given you where this one is a binomial and this one is a binomial. So you have to wait on this negative sign. You have to pass, like do this first. What would that be right there? 4x to the 6th, and then you'll subtract it. Okay, and then you'll do the next one, which will be 12x to the 4th, and then you subtract it, all right? So go ahead and see if you can expand this out. I'll write the expansion down here and see if you get the same thing. Let's see. Why did I do that? Okay, 4x to the 6th, 12x to the 4th. How many of you were able to get to that? Good? I'll show you something real quick. If you want, with these minus signs, you could just put a parentheses here and keep these all as, you know, whatever they turn out to be. So you're ignoring that. You just do all this, right? Put that in parentheses, and then later on come through with your minus. If you need to take it a little slower, you can do that. Understand what I mean by that? Yes? Yes? Okay. It's up to you. That negative would get distributed and become this. Now you collect like terms, right? Collect anything together. So we should get a final result here. Thinking we get negative x to the 6th. Just kind of cancel them out as you go. To the 4th, 6th. minus 8. X to the 4th. That's 6 of them. Took away 12, took away another 2. X squareds. No x squareds, right? They're all gone? Did I mess something up?
No.
I'm good? You have a question? You sure? Okay. And then we still have plus 3 in here. And then all over the denominator squared. Okay. Made it. So this would be the derivative, right? Okay, I have one additional thing I want to add to this. All right, we got the derivative. Now here's what I want you to do. Same problem. Find equation of tangent line at x equals -1. So all of this, the mechanical part here, we got the derivative, right? That allows us to find the slope of the tangent line, right? Anywhere? I would like to know what the equation of the tangent line is. Question? No, that's the question I'm asking you. How do you do this? So, how do it?
F of x plus h minus f of x.
Do what? Say again? We need to, okay, so we need to find the equation of a tangent line, right? Which means we need to find the equation of a line. We've done this before, and what we need is to use this formula, y minus y1 equals m times x minus x1. Now look, very important that you understand the difference between me asking you to find the slope of the tangent line at x equals -1 versus the equation of the tangent line. Those are two different questions.
Because we haven't gotten the slope, we got to input negative.
That's right. We don't know the slope of the tangent line yet.
Yeah.
But we can use the fact that they want us to look at -1, right? At -1, what is the slope of the tangent line? Well, plug -1 into this. And that'll give you your slope, right? Then what we need is a point on the line. And that point has to live on the original curve, which means we'll have to plug -1 into this. All right, so there's two parts we have to do here. All right, so let's find this slope first. To find the slope, we plug x equals -1 into y prime. All right, that's how we're going to find m. So the slope of this will be, all right, we're plugging -1 in here. So -1 to the 6th power is +1, right? But then it's negative. You have to look at that as being -1 to the 6th. And order of operations means you do this first and then bring the negative in. So we're going to have -1. And then here, when we plug in -1 for this, we get -1 positive, right? It's going to become +1, and then times -8. So we have -8. And then +3. All over. Now, -1 to the 4th is 1, plus -1 squared is still 1, or turns into 1, and then 1. So this is going to be 1 plus 1 plus 1, which is 3 squared, which is 9. And on the top, we get -9 plus 3, so -6 over 9, which is -2/3. So the slope of the tangent line at that point is -2/3, right? And what is the equation? Hugo, do you mind turning top left, all that black thing, turn it to the on position? Thank you. Yeah, good. So how do we find the x1, y1 part? Well, x1 is just x equals -1, right? I mean, that was already given to me. But to find y1, we're going to plug x equals -1 into the equation for y, right? Into y. That'll give us the point on this graph. So what happens when we plug -1 into that? So if we plug in -1, x equals -1 into this, we get, what's -1 cubed? -1, and then -1 times 3 minus 3 over, that gives us what? 3 on the bottom? So we get -4/3. All right, so at the end of the day, we have this. We have the slope of our tangent line is -2/3, and we have the point, the actual point on our graph, right? This is the point that lives on our graph. And this is the slope of the tangent line there. So now we're going to plug into this formula. So I should get y minus a -4/3, which is going to be +4/3, equals the slope, which is -2/3, and then x minus a -1, which is +1. So that's the equation of the line. I'm going to solve it for y. I'm going to distribute the -2/3 through on the right, which is -2/3 x minus 2/3. They were negative, so it makes them both negative. And then finally, I will add subtract 4/3 from both sides. And we get our final result. The equation of this tangent line is y equals -2/3 x, what? Minus 2. Because it becomes -6/3, right? That is the equation of the tangent line. So if I were to graph this, right? I don't know how quick this is going to come up. Let's see here. Is there anyone who wouldn't mind erasing everything except... Well, you know what? Can someone erase all that for me? You're going to be on camera, but... You can just get rid of all of it. I'm going to log. I want to graph this, okay? Because I made up the problem. I just want to let's just verify that it worked. And then I'm going to take off for the rest of the day, and you'll just finish it up for me while you're up there. All right. Thank you. Let's see. I've shown you this Desmos, right? But it doesn't like it. There we go. All right, the original function was, what was it? x cubed plus 3x over x to the 4th plus x squared plus 1. Okay, that's kind of a cool looking function. And then at -1, can you all see my cursor here? Okay, at -1, here's -1 right here. We're gonna have the graph draw our tangent line. It better hit that point, and it better look tangent to that. I'm feeling good. Why am I feeling good about it? Yeah, what's the slope of the tangent line need to be here? Positive or negative? Negative, and what was ours? -2/3. So I'm already feeling pretty good. So I'm going to put in, it was -2/3 x. You can write 2x over 3, it's the same thing. And then it was -2? There it is. Okay, so we just found the slope of the tangent line on this curve at -1. So there it is. Or we found the equation of the tangent line. Okay, Hugo, can you kill that for me? Thank you. All right, let's do something else. Okay, you'll enjoy this one, I think. This example. What is the derivative of tangent x? Secant squared x? Why? Just because? I haven't told you that, have I? I showed you the formulas, right? I said you should memorize these. I showed you that the derivative of sine was cosine, right? I did that. I used a sum formula from pre-cal to break down the limit, and I was able to prove that to you. And I said cosine goes the same way, but I never showed you the derivative of tangent. I just told you to take it on faith, right? Okay, so watch. I'm gonna try and show this to you now. So do you agree that tangent x is sine x over cosine x? So that's the same question I'm asking you then, right? And isn't that a quotient? That's a quotient. So you can look at the numerator as being f and the denominator as being g, right? So the derivative of this should be the derivative of the top, which is cosine x, times the bottom, which is cosine x, minus the derivative of the bottom, right? Derivative of g, which is negative sine x, and then times the top, which is sine x, all over the bottom squared, cosine x, that quantity squared. That is the quotient rule on that, isn't it? And do y'all recognize the numerator? That's cosine squared x minus minus is plus. Plus sine x times sine x is sine squared x all over cosine squared x. Now do you recognize the numerator? That's the all-important Pythagorean identity. Sine squared x plus cosine squared x is 1. So the top is really 1 over cosine squared x, but that's the same as 1 over cosine x, that entire quantity squared. Let's make sure you understand this. When you square this fraction, you square the top and bottom separately. You can do that with division. So when you square 1, you get 1. When you square cosine, you get cosine squared. But what is 1 over cosine by definition? Secant. So this is really secant x, right? Squared, but we write that secant squared x. So the derivative of tangent x is secant squared x. Now, you would never really want to prove that the derivative of tangent x is secant squared x using the limit. Okay, the old definition. This is what makes these rules so powerful, is that if I want to find the derivative of tangent, and I already know the derivative of sine and cosine, I proved those already, then I don't have to use the limit anymore as long as I can get everything in terms of sine and cosine. Then I can use the quotient rule or product rule and work out what the answer is. You can do the same thing for all the remaining trig functions. For example, what is the derivative of secant x? What's the derivative of secant x? Well, you would first rewrite secant x. What is secant x? It's 1 over cosine, right? So I could rewrite this as 1 over cosine x. What's the derivative of that? So look, do we have quotient? Do we have the quotient rule here? Do we have an f and a g? Now, it's going to be a little weird, but watch this, all right? This is f, this is g. First part of the formula, what is the derivative of f?
0.
0. Put it down. 0 times g, which is cosine x, and then minus the derivative of g, negative sine x. I forgot the negative. Negative sine x times f, the top, right? With no derivative, 1. All over the bottom squared. I'll just write as cosine squared x. Is that all right with you? Now that 0 times cosine is gone, right? This is gone. And the minus minus becomes plus, so all you have is sine x there, don't you? So what we get is sine x over cosine squared x. Now if you go back and look in your notes, I told you that the derivative of